Hello, I'm John Nightingale, a director at JCT and the symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Hi, good afternoon, everyone. My name is Raquel Velasco. I'm the product manager for the Smart Junction solution at Vivacity Labs. So many of you will already be familiar with our sensor product. Our AI-powered sensors provide councils and local authorities with accurate real-time positions and direction data for different types of road users. So additionally, we've also developed AI-based prediction models where we use this data and can forecast into the future to predict traffic volumes. And while we've continued to develop and grow our data and sensor capabilities, recently increasing the number of road users that we can differentiate between to more than 20 different classes, over the past 2 years, we've been making the leap from passive monitoring to active control. We're leveraging the data sets that our sensors provide, using our expertise in AI and data to build a system that not only more effectively reduces congestion, but also offers citywide optimization and pedestrian and cyclist prioritization. Over the next 5 minutes or so, I'm going to present the system that we've created and have been deploying across Greater Manchester. And after that, I'll hand it over to David Watts from TFGM, who's going to talk to you about this project from TFGM's perspective. And he'll finish off with our next steps and sort of what the future brings for us. The challenges with existing UTC systems are well understood and lived by many of you on this call today. Detection loops that are costly to cut and to maintain, systems that require manual calibration and recalibration, the trade-offs between regional coordination and localized congestion reduction, significant limitations in true multimodal prioritization, and the challenges of implementing high-level policies for addressing the climate emergency and the post-COVID recovery effectively at a local level. So at Vivacity, we're developing a system that not only looks to break new ground on these limitations, using our sensors for effective multimodal prioritization, and also creating a novel policy-based algorithm that can optimize for your chosen objectives and thereby give you the ability to optimize for active travel or air quality. We're also looking to improve on the existing systems. So with ultra granular real-time data on vehicle positions and types, the system has a more holistic view of the entire network conditions. This system will also dynamically optimize for changing traffic conditions, able to seamlessly transition between a focus on regional coordination and localized queue clearing. All of this without the need for manual calibration. This system is the outcome of a 3-year Innovate UK co-funded program. We've partnered with Immense Simulations and Transport for Greater Manchester to revolutionize the way that traffic signals are controlled by using AI to optimize traffic networks. What we set out to do was to develop a modern approach to signal control that enables local authorities and councils to implement strategies to prioritize not only for reduced congestion, but also different road users and different vehicle classes, and also for air quality. The solution that we've created starts with best-in-class data. Our Vivacity sensors provide classified counts, speeds, occupancy, and ANPR data, which is used both during control and initially to create and build and calibrate a traffic microsimulation. This simulation is as close to a true representation of the real-world environment as we can get. The AI that we are using for control is a reinforcement learning algorithm, which is trained in the simulated environment over thousands of hours of simulated traffic. By being allowed to explore and experiment and learn from its decisions within this safe space, it learns what good traffic signal behavior should be. At this point, it's ready to be deployed into the real world. We've developed a hardware platform that we call our Vivacity Intelligence Unit, or VIU, which is installed at the roadside and communicates the actions requested by the algorithm to the controller. And alongside all of this, we're also creating an intuitive and meaningful UI to give engineers greater visibility over overall traffic conditions around the network and the controller actions. So where are we now? I think the big headline here is that the system that I've just described is not theoretical. It is actually live across 3 junctions in Greater Manchester. When we spoke at last year's JCT, we successfully completed the test bench phase and demonstrated not only a functioning system, but more importantly, a safe system. Since then, we've deployed our system and begun controlling traffic signals in the real world, starting with our first trial junction in Salford early this year. And over the past year, we've scaled up to 3 junctions, initially controlling each of them individually, but now we've successfully deployed the system simultaneously across the region of 3 neighboring junctions in Greater Manchester. This journey into real-world control has come with quite a lot of learnings, so I'm going to cover a few of them now. We've observed closely each of the deployments and the actions that the system took, making sure that the agent or the algorithm was making sensible decisions. With each subsequent deployment, we've taken these observations and continued to improve the performance of the system. The figure here on the left shows the performance in simulation of the first 4 control algorithms that we deployed at our first trial junction compared to our baseline. What you can see here is that with each subsequent deployment, we will take these real-world learnings and improve on the performance. One of the biggest challenges that we've been facing is performance comparisons, particularly because what we are controlling are areas that are normally under Scoot control. This makes getting a true like-for-like comparison in the real world and in simulation challenging. So one of our main research focuses at the moment is to start to close that gap between performance that we've seen in simulation and the performance in the real world. As well as all this, we've also had some infrastructure limitations and connectivity challenges. And what that's prompted us to do has been to redesign some of the hardware components of the system. And we've begun to develop a solution that's actually completely wireless. All in all, it's been an incredible year. We're excited about the early performance results that we've been able to see. With a reduction in journey times of up to 22% across this 3-junction trial region when compared to their normal operation, we've actually also seen some early signs of emergent coordination. So we're really looking forward to continuing to improve on this in performance and to grow our control region across Greater Manchester over the coming year, particularly into areas that have greater pedestrian and cyclist traffic. Thank you so much for listening. I'm going to hand it over to David now, who's going to talk about his project from TFGM's perspective.
Hi, yeah, thanks Raquel. So yes, hopefully in the next few slides, I can show you how we've collaborated with the team at Vivacity over the last couple of years. And we really wanted you to see what the experience has been like for us so far during the deployments of the AI at the traffic signals, as well as giving an idea of some of the other benefits that we've seen throughout the project as well. I'll then share some of our hopes for the future in terms of the system and how we ultimately hope this work will better empower and equip transport bodies, as well as improving the experience for all road users. So just to give a bit of background about UTC at TFGM, we have a fairly substantial network to look after, the 2nd largest behind London in terms of number of signalised sites. And if anyone's seen the recently broadcast series on the BBC, Manctopia, you'll have seen we've a rapidly developing and expanding regional centre. And this is the area we tend to call around Manchester city centre and the Salford border. This actually forms part of the study area for the project as well. Like many others, we've got a varied network at the moment, operating Scoot, Mover, Fixed Time, etc. And with all the developments and changes going on, we need to often work quite closely with various authorities to ensure that the network is up to date in terms of timings and that things are operating as effectively as possible. And as we've all also seen recently, the coronavirus pandemic is yet another example of changes in travel behaviour that we of course have to take into account as well. To support these efforts, again, we've got a growing network of other assets, CCTV, Bluetooth, ATC, Google Journey Time data, for example, and often this data goes into different systems, and this of course brings its own challenges as well. So As Raquel's mentioned, we've been working on this project for a couple of years now, and I think it's fair to say we've made some quite impressive strides during this time. And with us approaching the final year, I'm hopeful that the best is actually yet to come. As kind of indicated on the slides here, we've had many meetings and discussions with the technical and project teams at Vivacity from an early stage throughout the project, bringing them into our control centre and really giving them the opportunity to shadow our engineers and immerse themselves in what we all know as the glorious world of traffic engineering. We've been able to share our approach of network management and also provide additional insight into the general hardware setup of our traffic signals as well. More recently, we've been sharing how the monitoring of our network has changed in the age of COVID-19. We've collaborated on the build of the overall system, including input into the general architecture and the user interface. And we feel they've really taken into account our thoughts on this and believe it's translated well into some early versions of the interface that we've seen. A good example of this is maintaining the ability to revert back to our UTC control at any time through the use of the special facility function. It has been and continues to be a positive collaboration with the guys, taking our comments on board, more recently with some changes to config files for the signal controllers that allow us to see the control and reply bits on our UTC system when the AI is actually in control. So let's have a look at the actual study area for the project. As you can see, we've targeted the installation of the sensors and the technology around this area. This is actually a screenshot I've lifted from the user dashboard, which shows the various count lines from the growing number of sensors we've got on the network now. And for those of you who know the area, you can see we've targeted junctions around the Manchester and Salford border, around the particularly busy areas of Trinity Way, which is the main ring road around the regional centre. The whole area actually forms one of the largest scoot regions, constituting of upwards of 25 scoot nodes. And due to the number of ongoing developments, as well as the high profile nature of the area, the sites are often frequently changed and amended, etc. You can see on the map where the red circles are. This is actually where we've had the Vivacity outstations installed on site, and where the AI has actually taken control on a growing number of occasions. From the rest of the count lines indicated on the map, you can see where we're hoping to expand the trial for the rest of this year and into next. So what you can see on the screen now is actually a screenshot from the junction dashboard that Vivacity have developed. And as you can see, the stages can be seen and numbered in relation to a map layout of the site, along with the control and reply bits here. And from our perspective, I can say we've been overall quite happy with how the AI has performed. You know, we've closely monitored the timings when the AI has been in control, observing how it's taken certain decisions to serve different stages during varying demands of traffic. We've been able to make use of extra functionality of the sensors too, using live CCTV footage, which has really added extra value to the hardware as well. We're really keen to push this further, particularly at the moment when traffic flows may not be typical. We're looking at the system to be able to better adapt to new trends quicker, especially where we're seeing an uptake in active travel modes such as cycling and walking. We've seen some positive evidence of this so far, for example, with the system picking up pedestrians and ped stages being served without the need for a push button, for example. I also just wanted to quickly talk about some of the other benefits we've seen from having this vast network of sensors. We've been able to make use of the really high level, the detailed level of data that we've been receiving. And whilst it may be being used to inform the AI, we've actually learned a thing or two ourselves over the last couple of years as well. Perhaps most interestingly are the recent findings during the COVID pandemic. Now, there are absolutely tons of graphs which could show you on this, but this one in particular shows our ped counts across the regional centre, looking at trends during lockdown against various changes in policy and other activities. You can see we've highlighted some of the milestones on the graph here, where you can clearly see the peak for the Black Lives Matter protest, for example, as well as the return of non-essential retail and hospitality too. It's been really useful for us to collect this sort of data and helped us move towards what Raquel has alluded to as a more predictive approach to managing the network, giving us examples of various scenarios and events, particularly from a cycling and walking perspective, as we emerge from lockdown as to what we keep hearing is the new normal. So where do we go now? Well, in terms of the project itself, we're confident we'll be able to expand the system to the rest of the study area, which at the minute is looking around 15 sites or so. Like our partners at Vivacity on this, we're really keen to push the AI to continue to take control during the busy peak periods, observing and analysing how it performs, especially compared to the existing Scoop control. One area that will be particularly challenging will be extension of the trial down Deansgate, which is a recently partially pedestrianised route in the city centre, where balancing heavy pedestrian and cycle flows along with busy bus routes crossing through will be challenging. So yeah, can't wait to get our teeth stuck into that one. And obviously in this new normal, we are particularly keen to push the cycling and walking components of the project, with a number of these sites falling across areas of high pedestrian and cycle volumes, where we'll be looking to better support these travel modes get around the city region. It's quite clear now that authorities must adapt, particularly in the current circumstances when the future is uncertain, and we now need more than ever to be able to effectively manage transport networks in what's going to continue to be a changing landscape going forwards. And hopefully, as a result of this project, we'll be in a better place as engineers to do that, with the tools in place that allow us to be more responsive, more informed, and hopefully spending less time revalidating junctions, regions, changing parameters, that sort of thing. So yeah, thank you very much for listening. I hope it's proven useful and given some insight into what we've been doing on the project.